Welcome to day 2 of our online classroom. We are moving on today. Hopefully you're able to finish those first 2 topics you were assigned yesterday. If you were not, make sure you're going back and trying to get through those today, as well as tackling the 3 that we're going to do for today, which is Thursday, March 19th. The first topic we're going to look at here is probability involving one die or choosing from n distinct objects. And the idea behind this is that we're going to have a certain amount of possible outcomes, and we have to determine how many of those outcomes will make our certain situation happen. So if you take a look at this first one here, it says a bag contains 8 tiles labeled F, G, H, I, J, K, L, and M. One tile will be picked randomly. What is the probability of picking a vowel? So in general, what you want to do is turn it into a fraction. You see it right here, it says fraction in simplest form. The big thing you want to know is that the bottom of your fraction is going to be all of your possible outcomes. So however many different outcomes you could possibly have is going to go on the bottom. On the top, it will be the different outcomes that are going to make your situation happen or make your situation successful. So for this one, what would go on top is how many different letters we could pick that will end with us picking a vowel. So if you look at these letters that you're given here, you're told that there are 8 tiles. So we know right away that if you're drawing one tile randomly, you're going to get 8 tiles as your potential outcomes. From there, you just have to figure out how many of these letters are vowels. So you see here, the only vowel that I see is the I. So we're going to put a 1 on top because there's only one possible outcome that's going to make this situation happen. It says write your fraction in simplest form. 1/8 is already simplified, so that is the probability that you draw a vowel out of this bag of tiles. Let's take a look at another one. Another bag with a bunch more tiles in it. We got A, B, C, D, E, F, G, and H. We're still picking one tile randomly, and we want to know what is the probability of picking a letter that is not a vowel. So if you remember on the last problem we did, we said that the number of possible outcomes was going to be on the bottom, and the number of successful outcomes was going to be on the top. In this case, once again, the possible outcomes is just how many tiles we have, and we're told from the start that there are 8. Now, to figure out which letters are going to make this successful is a little bit more complicated this time around. So what we want to look at here is what they're asking. What's the probability of picking a letter that is not a vowel? So if you go through the 8 letters that you're shown here, it might be beneficial to circle or underline the letters that are not vowels. So if you take a look here, B, C, D, and then F, G, and H are all not vowels. A and E are the only vowels you have there. So if you take a look at how many different outcomes you could have that would result in you not picking a vowel, that would be 6. Now here's when the fraction in simplest form comes into play, because 6/8 is not simplified. We need to reduce that fraction and turn it into 3/4. If you try to put 6/8 into ALEKS, a lot of times they give you an error message and say that you have to simplify your fraction. So you might as well just do it right away. And you see here that 6/8, which is your number of possible outcomes on the bottom, your successful ones on the top, we can simplify that to 3/4. So 3/4 of the letters you have here result in you picking a letter that's not a vowel. Here's an example where we have balls that are numbered. Again, we're using a bag. In this case, we have 12 balls. And you have 1 through 12, and you're picking one randomly out of the bag. So looking at your possible outcomes, once again, it's just how many different numbers you could possibly choose. In this case, we have 12 different balls with 12 different numbers, so we would have 12 as our possible outcomes. Now what this one is asking for is, what is the probability of picking an even number? So if you think about it, you could write out all the numbers 1 through 12, or you could realize that, or remember that odd and even numbers basically just alternate. So when you've got numbers 1 through 12, every other number is going to be even. So you got 2, 4, 6, 8, 10, and 12. So out of those possible outcomes, 6 of them would give me an even number. And as you can see, 6 over 12, that's a fraction that can be reduced as well. We can reduce that to 1 over 2. So the probability of picking an even number is 1/2. This one here, it says a 6-sided die with sides labeled 1 through 6. So a standard die. And it says each number is equally likely to be rolled, which means that it's just a standard die. It's a fair die, so to speak. The question that we're asked here is, what's the probability of rolling a number greater than 2? Well, if we have a 6-sided die, the possible outcomes that we would have there are the numbers 1 through 6. And if we're looking at which outcomes would give us a number greater than 2, we would have to include 3, 4, 5, 6. So this is where some inequalities kind of come into play here, because it does say greater than 2, which means that 2 is not going to be included in this successful outcome group here. So out of the 6 possible ways that a roll of the dice could end, you would have 4 out of 6 that were successful. And then of course our last step, ALEKS wants your fractions in simplest form. 4 over 6, we could simplify that fraction to 2/3. And that would be your answer. So I've got one more left here for you. Now we have a 12-sided die. You don't see a lot of those around, but we got numbers 1 through 12. Each number is equally likely to be rolled. What is the probability of rolling a number less than 4? So if you got 1 through 12, the 3 possibilities that are less than 4 are 1, 2, and 3. So your number of possible outcomes, as we know, would be 12. And the number of outcomes that are successful, so to speak, would be however many numbers we have that are less than 4, which in this case is 3. Again, you have a fraction that can be simplified, so you simplify that to 1 over 4. If the simplifying of the fractions is a struggle for you, look back in ALEKS in chapter 0, and there will be some topics that you could either review or that you can go in and do that'll help you reduce fractions. So that's it for this topic. If you have any questions, please post questions to our Google Classroom or send an email to myself, Ms. Pointner, or Mr. Malachnik.